Today we're going to talk about symlinks and the difference between soft links and hard links. I also wrote a blog post covering the same thing, so if you prefer written format, be sure to check out the blog post and the link in the description. So the first thing we'll do is create a test directory. So go ahead and make directory test and change into it. And basically a symlink is a reference to a file from another location. And a soft link is links to another file without actually being a file. So it's just a path. So it carries a path to the original file. So we could do something like let's go ahead and create a dog file. So echo woof to dog.txt. And then we have a dog.txt file, which we can see the contents of it with cat. And then let's say I want to access that file from the desktop. I can create a symlink to the dog.txt file. So I'll do ln with the s flag, the lowercase s, and then we'll go into the, we'll choose the dog.txt, and then we'll create the softlink file. So I'll call it softlink1. Okay, so then I've got this softlink1 softlink here that leads to the dog.txt. So if I do cat.softlink, I get woof. And then if we were to try to add something to the softlink, and we do it again, we'll get woof from softlink and the woof. So we've appended this onto both the softlink1 and the dog.txt because softlink1 isn't really anything other than a path to dog.txt. So if we print the file, or if we print the results of dog.txt now, again we get woof from softlink because we added the content to dog.txt through the softlink. And so the thing about this is it uses the way that we have it set up, it's using a relative path. So if we were to move the softlink somewhere else, let's say we move it into the test directory, and we try to cat the softlink now, it's not going to work because we used a relative path. So what you would have to do is you'd have to fix the symlink anytime you moved either the target file or the symlink file. So we broke the file, or we broke the softlink by moving it, and fixing it's not that hard. You can just go to the file or the softlink, and then we can I believe it's ln fs. F would be to unlink any existing links. So we have a broken link, so we would unlink it, and then we create the softlink again. So we do, but this time we would have to change it to the correct path again, which is this time is dog.txt, and then because they're both in the same directory, you would just do dog.txt softlink1. Okay, and then we can cat softlink, and there we go. And so the idea is with symlinks, the reason that we recommend using, or that generally it's recommended to use relative paths, is because they're supposed to be like self-contained, like within the program. So if I was to create a program and ship it, and it had symlinks in it, if I used an absolute path, it wouldn't work on your computer, it would only work on mine. And also, maybe you want to change the location of that program. So maybe we want to move the test directory into the home directory of the user. So we can move the test directory down one, and go back into test, and then we can cat soft link, and it still works. So that's the idea of using relative. Like if you were to use absolute paths, none of that would work, and you'd have to remake the soft link. So that, in a nutshell, is how soft links work. And I guess one thing that we should do is take a look at all of the different information on the soft link. So you can see in the command line, if you do an ls-li, you'll see the soft link has like a little arrow that points to the dog.txt. And you'll see that it has execute access, so it's slightly different. And that, in a nutshell, is soft links. So soft links are a great way to reference the same file from multiple locations. And you can also link to videos or basically any type of file. It's kind of like a shortcut. A hard link is another type of symlink, but it has a slight difference. And the best way to describe that is through an analogy. So think of it like having a room in a house, and the room has one door in it. It has one door to get into the room. A hard link is basically like cutting a hole in the wall and making another door to get to that room. So if you think about it, the contents of the room is the file, and then the hard link is just another door to get into that file. So I'm going to go ahead and move the test directory back to the desktop, and we'll go ahead and start back in there. And so we've got dog.txt and a soft link. But let's go ahead and create a hard link. So we'll do ln dog.txt and hard link. We'll call it hard link. And that will create a hard link by default. So we'll create a hard link. And now if we do cat hard link, we get woof and woof from soft link. And so we can add a text just to make sure. Echo woof from hard link. Okay, and then cat hard link, yep, and cat dog.txt. So it looks like it's working, and that is basically the hard link. But what you'll notice if we do ls-lia again, you'll see that the hard link and dog.txt share the same inode information, meaning that they share permissions, and they also share the data itself. So it's like two separate doors into the same file. So, and so because of that, because the soft link is just a path to the original file. So if we move dog.txt, the soft link is going to break, but the hard link will not. So let's go ahead and move hard link back to our desktop, and then we'll cat the hard link. And we see that it works. So if we were to make another directory in the test, and we'll call it nested folder, and we'll move dog.txt into nested, and then we'll go into the nested folder, and we'll go back to the test folder, and we'll try to cat the soft link. And it's not going to work because of the relative path. But if we try to cat the hard link, it works. So because, again, the hard link actually has access to the data, it's not just a path to the file. So if we move the hard link and the dog.txt back into the test file, and we change the permissions, you'll notice that the dog.txt and the hard link stay the same. So let's do LSL, and we'll see that dog.txt and hard link have read, write, read, and read. So let's do sudo change mod all. Let's give all users execute access. Oops, and I messed up. Okay, for the hard link only, right? Okay, and now LSL, and you'll see that execute access was given to the hard link and the dog.txt. And well, I guess SoftLink already had it, so it didn't change anything. But since I gave them execute access, let's take it away, and we'll see the difference. So um, sudo change mod take away execute access from the hard link, and we'll see that execute access was taken away from dog.txt and hardlink. So that's how hardlinks work. The last thing I can think of to cover is that with a hard link, you need to delete every instance of the file and all hard links in order to actually delete the data. So right now we have dog.txt and hard link. So if we were to remove dog.txt and then try to see hard link, we still have it. And then if we were to add some more stuff to hard link, that file is still there. So we need to delete everything, all of the hard links and the original file, in order to completely remove that file. And so in a nutshell, that is hard links and soft links. Soft link is just a path to the original file. So when you edit the soft link, you're actually just editing the normal file from a different location. While the hard link itself is it's almost like a copy, but it's more of like another door to the same file. And you need to delete all of the hard links in order to get rid of that file. So I hope that makes sense, and that's it.
Thanks for watching the video, everybody. I hope this was super helpful. Go ahead and check out my website, truthseekers.io, and check out all of the stuff that we have on there. I'm trying to build a community of programmers and technology enthusiasts. So check out what we have, see if you can solve some of our programming challenges and stuff like that. So yeah, check it out. Have a good day.